Hi gentlemen, these will be your notes for Unit 3, Day 2 of Algebra 1. If you would like to see the warm-up question, review question, which we did in our last unit, or any homework questions we covered today, just look at the finished notes that are posted. All right, gentlemen, so today we're going to talk about linear functions and equations. How can you identify if a given equation is going to be linear and what it means to be linear? We'll also graph equations by finding and plotting ordered pairs using a table. So identifying linear equations. What do you guys notice about the word linear? Or what do you think the word linear is going to mean? It's going to mean that when you graph it, so when you graph the equation, it makes a line. So it makes a straight line. So a linear equation is any equation that you graph, it will make a straight line. So examples of linear equations, and maybe you guys have seen some of these before, like you have your y equals mx plus b, if you remember slope-intercept form. So like y equals 2x minus 3 would be a linear function, because if you graphed it, it would end up looking like this. And so when you graph it, it makes a straight line, so it would be linear. Another example of a linear function would be like 2x plus 3y equals 6. Because if we graphed that function, it would look like this, which would also make a straight line. So their graphs make a straight line. Another example of a linear function could be y equals 4. Because if we graph that equation, it would look like this. And again, it makes a straight line. So those are examples of linear equations, because when you graph them, they make straight lines. Examples of things that would not be linear would be y equals x squared. Because if you graph y equals x squared, it ends up looking like this, and that's called a parabola, which is not a straight line. Another example of something that would be nonlinear could be like x squared plus y squared equals 4. Because when you graph that, it ends up looking like a circle whose radius is 2. And another example of something that would not be linear could be y equals the square root of x, because his graph ends up looking like half of a sideways parabola. So what do you notice about the things that are linear and the things that aren't linear? In all of your linear examples, you have an x and a y, except for the y equals 4. So typically you'll have an x and a y, and there's no exponents. They don't have any exponents on them. In the non-examples, you have x's and y's, but they have exponents or square roots. So things like that. That would make them non-linear. So how do we graph linear equations? By just using a table. Well, the good news is you can pick any values for x that you want to. So you can pick any x values you want for the table. Some are going to be nicer than others based on the equation, but you can pick any x values you want for the table, and then you just solve for the y values. So that's how this is going to work. So for instance, I can pick any x value I want, so I'm going to pick 0. So I'm going to take that equation, x minus 4y equals 8, and I'm just going to plug in 0 for x. So this is going to become 0 minus 4y equals 8. So again, all I'm doing is I'm substituting in for that x in the equation. And now if I solve this, I have 0 minus 4y equals 8, so divide by negative 4, divide by negative 4. And that means that the y value that goes with 0 is negative 2. I can pick another x value. I'm going to pick 4. So if I picked 4, 4 minus 4y equals 8. So to solve this, I'm going to subtract 4 from both sides. And negative 4y equals 4. And then divide by negative 4, divide by negative 4. And y is going to be negative 1. I'm going to pick another one. I'll pick 8. So if I have 8 minus 4y equals 8, I'm going to subtract 8 from both sides. And I have negative 4y equals 0, because 8 minus 8 is 0. Divide by negative 4, and I get y equals 0. I'm going to pick you can also pick negative numbers. What if I pick -1? So if I plug in -1, I have -1 minus 4y equals 8. I'm going to add 1 to both sides, and I would have -4y equals 9. Divide by -4, and y is going to be -9/4, which I don't know how to graph, so I'm going to change that to a decimal so I do know where it would go. 4 goes into 9 twice with a remainder of 1, so it'll be -2.25. We could pick another value. I could pick -4. So if I picked -4, what would I get? I would get -4 minus 4y equals 8. Add the 4 to both sides. And -4y equals 12. Divide by -4 on both sides. And y would be -3. So now we have a bunch of x values and y values. These are going to be ordered pairs. So that first one represents the ordered pair 0, -2. So I'm going to go 0 over and 2 down. The next one is the point 4, 1. So I'm going to go 4 over, 1 down. The next one is the point 8, 0. So 8 over, 5, 6, 7, 8, and then 0 up. The next one is -1, -2.25. So it'd be about right there. And then the next one is -4, 1, 2, 3, 4, and then 3 down. So right there. And then if I connect all of those guys, I get a straight line. So that represents a linear function because all of those points lay on the same straight line. All right, let's try another one. 3y minus 2x equals 6. So again, we can pick any values for x that we want to. I usually start with 0, so if I plug in 0 for x, I would have 3y minus 2 times 0 equals 6. 2 times 0 is 0, so 3y minus 0 is just 3y. So 3y equals 6, divide by 3, and y is going to be 2. So I have the point 0, 2. Let's pick, what if x is 3? So we would have 3y minus 2 times 3 equals 6. So we have 3y minus 6 equals 6. Add the 6 over. And 3y is going to equal 12. Divide by 3, and y is going to be 4. All right, let's pick a negative number. What if what if x is -3? So then we would have 3y minus 2 times -3 equals 6. So 3y, -2 times -3 is positive 6. So 3y plus 6 equals 6. Subtract the 6 from both sides, and 3y is going to equal 0. Divide by 3, and 0 divided by 3 is 0. So let's see if these are making a straight line. So 0, 2, 3, 4, and -3, 0. They look like they're falling all in the straight line. So that would be a graph of our linear function. You could pick some more points in your table if you wanted to guarantee that your graph was right. All right, so let's graph and see if it's linear. So now we have y equals x squared plus 2. So from our examples up above on our first slide, you should know whether or not this is going to be linear. But let's try. So again, you can graph anything by just picking x values. So if x is 0, y is going to equal 0 squared plus 2. Remember, if you substitute, you should put it in parentheses. 0 squared is 0, so 0 plus 2 is going to be 2. So I have the point 0, 2. Let's try 1. Y is going to equal 1 squared plus 2, which is 3. Let's try 2. Y is going to equal 2 squared plus 2, which is 6. Let's try on the negative side. What if it's -1? Y is going to equal -1 squared plus 2. -1 times -1 is 1, and 1 plus 2 is 3. Now let's try -2. If I plug in -2, y equals -2 squared plus 2. -2 times -2 is 4, and 4 plus 2 is 6. So let's see what happens when I graph this. So 0, 2, 1, 3, 2, 6, 4, 5, 6, -1, 3, -2, 6. So notice this is forming that same U-shaped as the one that I showed you in that example. This is called a parabola. So when you form a U when you graph, we call that a parabola. So when you graph a y equals x squared, it's always going to make that U shape. So graph, is it linear? So again, we can pick any value that we want for x, but notice there's nothing to substitute in because y is always equal to -1. So everything that we want, the y value is always going to be -1, but we can pick anything we want to for x. So I'm just going to do 0, 1, 2, 3, 4. And all of my y values are going to be -1. So 0, -1, 1, -1, 2, -1, 3, -1, 4, -1. And notice all of those are just making that straight horizontal line. And yes, it's linear because it makes a line. So y equals -1 is a linear function. So this one's yes. This one's no, it's not linear. And this one, oh, that one was just graph. All right, so let's try this one. Graph, is it a linear equation? So what if x? Well, actually on this one, we're going to plug in for y because y is the more complicated looking one, right? We have x plus y squared equals 4. So I'm going to plug in values for y because it's more complicated. So what if y is 0? What would x be? X plus 0 squared equals 4. So x is going to equal 4. So I have the point 0.04. What if y is 1? X plus 1 squared equals 4. So x plus 1 equals 4, which would mean x would be 3. What if I plugged in 2 for y? X plus 2 squared equals 4. So x plus 4 equals 4. That would mean x would be 0. Let's try -1 for y. So x plus -1 squared equals 4. That would be x plus 1 equals 4, which again, x would be 3 in that case. Or if I tried -2, x plus -2 squared equals 4. -2 times -2 is 4. So x plus 4 equals 4. And if you solve that, you would get 0. So if I graph that, 4, 0, 3, 1, 0, 2. And then 3, -1, and 0, -2. So this time I get a parabola again, but notice it's a sideways parabola because instead of x being squared, the y is squared. So this still is not linear because it's not forming a straight line. It's forming a sideways parabola. So graph, is it a linear equation? So remember when you see those bars, that's absolute value. So what does it look like when we graph absolute value? So again, we can pick anything we want to for the x. So let's do 0. What's the absolute value of 0 minus 2? Well, it's -2. Let's plug in 1. What's the absolute value of 1 minus 2? That's -1. What if we plugged in 2? What's the absolute value of 2 minus 2? That's 0. Let's try -1. What's the absolute value of -1 minus 2? That'd be 1 minus 2, which is -1. And what if I picked -2? What's the absolute value of -2 minus 2? That's 0. So we have 0, -2, 1, -1, 2, 0, -1, -1, and -2, 0. So notice this one almost looks like a parabola, but instead of a parabola, it makes a V. So absolute value graphs aren't linear, but they make a V. So they make two lines that go in opposite directions. But it's not linear because it's not one line. But absolute value graphs look like a V graph. So graph, is it linear? So y equals -2/3 x plus 1. So we're going to be creative on what we're going to plug in for x. Well, 0 is always a nice number. So y is going to equal -2/3 times 0 plus 1. Well, anything times 0 is 0, so y is going to be 1. Now, I'm going to plug in x's that are multiples of 3 because the denominator is a 3. So I'm going to try 3. So y equals -2/3 times 3 plus 1. Now notice what happens. So when you multiply fractions, remember straight across the top, straight across the bottom. And so you get y equals -6/3 plus 1. That divides nicely. -6 divided by 3 is -2, and -2 plus 1 is -1. What's another factor of 3? Let's try 6. So y is going to equal -2/3 times 6 plus 1. So over 1, just multiply straight across. So y is going to equal -12/3 plus 1, which is -4 plus 1, which is -3. Let's try 9. That's another factor of 3. So it'll cancel nicely with the denominator. So -2/3 times 9 plus 1. That would be -18/3 plus 1. So -6 plus 1. So that's going to be -5. So let's see if we graph this. Is it linear? So 0, 1, 3, -1, 6, -3, and then 9, negative 5. Well, all of those are on a straight line. So yeah, that's a linear function because it forms a line. All right, last one, y equals 2 to the x. All right, so the x now is up where the exponent would be. So if I do 0, do you guys remember what 2 to the 0th power or anything to the 0th power is? It's 1. And then if I do 1, 2 to the first power is 2. If I do 2, 2 to the second power is 4. Do you guys know what happens if I try negative 1? Do you guys remember the exponent rule? If it's 2 to the negative first power, that's when you drop it. So it becomes 1 over 2 to the first power. So you drop it into the denominator when you have a negative exponent. So it'd be negative 1 1/2. Or what if it was negative 2? So 2 to the negative 2, you would drop that expression to the denominator, and it would become 1 over 2 squared, which would be 1/4. So we have 0, 1, 1, 2, 2, 4, and then negative 1 1/2. Negative 2 1/4. So notice this isn't linear. It looks kind of like a ramp. So it starts low and then it shoots up. We call this an exponential function because the exponent is a variable and it's not linear. All right, gentlemen, your homework is from 3.2. If you have any questions,